Welcome back, everybody. In today's lesson, the last lesson of our topic, we're going to learn how to simulate compound events. And so when we simulate something, that's when we're producing kind of a model. So we're producing a model of something that's happening without doing the actual thing that's happening. Today we'll learn how to simulate compound events to approximate the probability. We'll use spinners, dice, and something called a random number generator to simulate these compound events. Now, it says Jillian lands the beanbag in the hole in about half of her attempts. So I'm going to circle that. In a beanbag tossing game, how can she predict the number of times she will get the beanbag in the hole in her next 5 attempts using a coin toss? So the coin has heads and tails. You can have heads stand for get it in and tails for a miss. And we can flip the coin to see how likely it is. She gets the beanbag in the hole. It says Nikki is planning a hike for the end of the week. She really does not want to hike if it's raining the whole time, but it's okay if it's cloudy. Based on the weather forecast, should she postpone her trip? So there's a 40% chance rain on each of the 3 days. So first we're going to develop a probability model for rain on a given day. For 40%, 40% is equal to 40 over 100. Which equals 4 over 10, which equals 2 over 5. So when we look over here at the spinner that was made, you'll see that 2 of the sections are for rain, and the other 3 are for no rain. That's because the probability of it raining is 2/5 or 40%. 2/5 of the spinner show rain, and the other 3/5 show no rain. So this is what's called a simulation, because we're not really waiting to see whether or not it rains or not. We're doing something beforehand to simulate or to stand in place of or to model like a stand-in. So what we're going to do is we're going to run the simulation. We're going to spin the spinner 3 times, once for each day, and then record the results. So this means that it rained, this means that there's no rain and no rain. And so this was done a total of 5 times. You'll notice that there's no days where it rained all 3. There's no trials, rather, where it rained all 3 days. Here it rained twice. Here there was no rain. Here it rained just once. So based on this simulation, Nikki should expect rain on one day of the 3 days. So she shouldn't postpone her trip because it's not going to be a complete washout. It says down here that there's a 50% chance that a volleyball team will win any one of its 4 remaining games this year. A spinner with 2 equal sections numbered 1 win and 2 loss is used to simulate the probability that the team will win exactly 2 of its last 4 games. So do the following. So circle the word for. Okay, so I want you to circle the word for, and the reason is because that's why the numbers are in groups of 4. So see how each of these numbers here are in groups of 4. We want to check to see how likely it is that they win exactly 2 of the last 4 games. So we're looking for exactly 2 ones. So right there, that's exactly 2 ones. We're not going to count that. We're this one and this. We're not going to count that. Not going to count. We're going to. So what we did is we circled all the times. There were 2 ones. Exactly. So out of the 10 trials, there were 4 favorable outcomes based on the simulation. The probability that the team will win exactly 2 of its last 4 games is out of 10 or 2 out of 5 or 40%. Next, we're talking about 2 teams, the Hornets and the Tigers. They play a 5-game series. With the winner of 3 games named the state volleyball champion. The 2 teams are evenly matched. Use a simulation to find the probability that the Hornets will win the 5-game series. So the reason we're using a coin flip So the reason we're using a coin flip is coin flips are 50-50, or they have a 1/2 probability, just like a win or loss. So the probability that the Hornets win and that the Tigers win is 50-50. So if you flip the coin and you get heads, then that means that the Hornets win, and tails means that the Tigers win. So you come over here. This means that the Hornets win 3 of the 5 games, so the Hornets win the series. Here, the Tigers win 3 of the 5. Here, the Hornets. See what happens with the rest. So based on the 7 trials, there were 1, 2, 3, So 4 out of the 7. It's a probability of 4/7 that the Hornets will win the series. It says Carl hits the target 50% of the time he throws a ball at it. Carl uses a coin to simulate his next 3 pitches. He assigns H for a hit and T for a T for miss. The results of 12 trials are shown below. So because the probability is 50%, that's why they're using a coin flip. There are 12 trials. And we have to find the probability that Carl will hit the target exactly to his next free throws. So we're looking for two heads out of 3. So 2, 3, 4, 5. So the probability that Carl hits the target is 5/12, which is just a little bit below 50%. And then the last page I'll do with you is using something called a random number generator. And so a random number generator is a piece of software that produces random sets of numbers. It says an energy bar company is printing equal quantities of 6 different collectible cards. The company will randomly package 1 card inside the wrapper of each energy bar. What is the probability that all 6 collectible cards will be packaged in a box of 10 energy bars? So what they're going to do is they're going to use the numbers 1 through 6 to represent the different trading cards. So the random number generator did these 8 trials. So there are 10 numbers in each trial. Because each box has 10 bars in it. What we do is we look for cases where the whole box has all 6 cards in it, and that only happens once. So this box has all 6 cards in it. So that means that there's 1 out of 8. Chance that box of bars will have all 6 collectible cards in it. So I'm going to cross this one out, and I want you to focus on number 5. It says Molly makes 70% of her free throws. The random numbers below represent 20 trials of a simulation of 2 free throws, using the numbers 0 through 9. So if we're using the numbers 0 through 9, %70 of those numbers start at 0 and we go up to 6. So that's 7 numbers out of the 10. So that's 70% of the numbers. Now, we're going to do 20 trials. So that's why you see that there's 20 trials here. And we're talking about 2 free throws, so that's why the numbers are in groups of 2. So we're going to let the numbers 0 to 6 represent successful free throws. 7 through 9 represent a missed free throw. And if we look at how many times she made both free throws, we're circling all the times where both numbers are between 0 and 6. So none of these, this one, between 0 and 6. So we had 1, 2, 3, 4, 5, 6. So 6 out of 20. Do 6 divided by 20 times 100. We get 30%. All right, the last one that I'll do is this one up here. It says survey results state that 80% of people enjoy going to the beach. Random numbers below represent 10 trials of a simulation of asking 2 people if they enjoy going to the beach, using the numbers 0 through 9 for their responses. So 80%, so 0, 1, 2, 3, so 80%. This can be confusing because you're thinking 80%, you would go up to 8. But remember, we're including 0. So if we count 1, 2, 3, 4, 5, 6, 7, 8, these are the first 8 numbers. And that's what we want, is we want 80% of the numbers. So 80% is 8 out of the 10. So we're going to use the numbers 0 through 7 to show people who enjoy going to the beach. 8 and 9 will be people who do not enjoy going to the beach. Exactly one of the 2 people enjoys going to the beach. So we want exactly one of the numbers to be 0 through 7. So that's it, not that one. So that one's not it because both are between 0 and 7. So we got 2 out of 10, which is 20%. All right, you're going to finish the last three examples, and then we'll tell you what to do next.